Good day, everyone, and welcome to the lecture series Complex Numbers. All right, today we'll start with the definition of complex number. And as we all know previously, we have talked about different kind of numbers: whole number, rational numbers, real numbers, natural numbers. Okay, the zero, the negative integers, and the positive integers. So today we're talking about complex number, and we define it to be z equal to a plus I. Okay, and here we see that the complex number has two parts: the real part, which is a, and the complex and the imaginary part, which is what? IB. Okay, and it is stated that I is equals to what? The square root of what? Minus 1. All right, which is the imaginary unit. So examples of complex number, we can have that z is equal to what? 3 minus 2i. This is an example of a complex number. Z is equals to 4 plus I. This is an example of a complex number. Z is equals to 3i. This is an example of a complex number. We can have as many as we want. And now, going to the conjugate of a complex number, you can see that it is defined as z, this is our z, equals to what? A plus ib. The conjugate of this complex number is the same thing as z bar is equals to what? A minus what? ib. So what it entails is whenever you have a complex number of this form, which is a plus ib, then the conjugate is interchanging the sign attached to the imaginary part. So if it is plus, you change to what? Minus. If it is minus, then it changes to what? Plus. So that is how you define a complex conjugate. For example, if we have, as you can see in example 1 there, you can see that z is equals to minus 4 plus what? 3i. The complex conjugate, which is what? Z bar is equals to what? Minus 4 minus what? 3i. That is the complex conjugate. And you can see for the b part, you will see that z is equals to what? 1 plus 2i. Then the complex conjugate, which is what? Z bar is equals to what? 1 minus what? 2i. All right. So that gives you the definition. So interchanging the signs attached to the what? Imaginary part. All right. So for the C, you can see it's 4i, and in the solution, you can see that it is what? Minus 4i. For the D part, we have that Z is equals to 3 over 5i. 3 over 5i. Then the complex conjugate, that is the conjugate of the complex number, is minus 3 over 5i. Then, with that being said, we move to the what? Algebra of what? Complex numbers. So we talks about addition and subtractions of complex number, multiplication and division of complex number. Okay. Now, in adding or subtracting two or more complex number, we add and subtract one, or subtract their real parts and imaginary parts separately. So it's more like collecting like them. In example 2, you can see that we are asked to find z1 plus what? Z2. Z1 Z1 is equal to 3 plus 2i, and Z2 is equal to 4 minus 4, 4 minus what? 5i. Then, so we have z1 plus z2 is equals to 3 plus 2i plus 4 minus 5i. So this is equal to 3 plus 2i plus 4 minus what? 5i. Then when you collect like terms, you can see that 3 plus 4 plus 2i minus what? 5i, which is the same thing as 3 plus 4 is 7. Then 2i minus 5i is what? Minus 3i. So you can see in this example here that z1 plus z2 is equals to 7 minus 3i. Following the same procedure, you can see that z1 minus z2 is minus 1 plus 7i, which is indicated here. Then in our next video, we will talk about what? Multiplication and division of complex numbers. Thank you very much for listening. Please do not forget to subscribe for more videos.